So now we have some formulas for when we do actually have an arithmetic series, which is basically the sum of an arithmetic sequence, or a geometric series, which is a sum of a geometric sequence. So of an arithmetic sequence, we have n divided by 2 times a sub 1 plus a sub n. Now, where does this come from? Here's a little side note for you guys. I always found this really fascinating. If we had an arithmetic series, 3 plus, let me add 4 every time. So 3, 7, 11, 15, 19, 23. Okay, let's do that. Because you were adding the same number every time, notice what happens when I add my first and my last term. That gives me a 26. Well, if I keep going inside, 7 and 19, guess what? That also gives me a 26. 11 and 15, that also gives me a 26. That pattern, when you're adding them, occurs in any arithmetic sequence. So I've got 6 terms there, but if I pair them up and add them in 2s, notice I end up with 3, or half of 6. I end up with 3 26s. That's where the arithmetic sequence formula comes from. Pretty cool, huh? So you add, oops, wait, there's an error. I don't know why I did that. A sub 1 plus a sub n. So you're adding your first and your last term multiplied by half of however many terms you have. Okay, again, that is an example up there. Geometric series, a little bit different. You're going to take your first term, a sub 1, and you have 1 minus r to the nth divided by 1 minus r. Little bit more involved as far as explaining how that one is than the arithmetic sequence. So we're just going to take that formula for granted right now. A sub 1 times 1 minus r to the n over 1 minus r. Now, before we do the examples, one thing that I want to note with these sequences is that these formulas work when we start with 1 and we go out to n for a sub k. So if the summation is not starting with the first term, then we may have to do a little bit of manipulation, but that's okay. We can do that. Let's think of it this way. If we wanted to know the sum of just 7 through 23, I would still add up all of these and then just subtract the first term from it, right? I can still use my formula and then get rid of the term that I didn't want to add. So that's what we're going to end up doing here. So notice first we have a linear formula, which means we have an arithmetic. So in order to use our formula, we're going to find the summation from 1 to 20. Okay, we're going to find the total summation. But since we don't want that first term included, we would just subtract whatever that first term is. That one would be easy to find. But this way we don't have to find all 20. So our formula then, since we have 20 entire terms, we're going to take the 20 divided by 2. So that means there's going to be 10 pairs that we add up. We want our a sub 1 plus a sub 20. Okay, I'm not plugging them in just yet. Our a sub 1 plus our a sub 20, that's our formula. But then we're going to subtract out our a sub 1. Notice they do not reduce to 0 here because technically what's in brackets is going to get that 10. Okay, pause it if you need to think about it for a minute. So 20 divided by 2 is 10. Our first term, we can do that over here. Our a sub 1 is going to be 2 times 1 plus 1 using this formula here. So our a sub 1 is going to be 3. And then our a sub 20, when we plug it in, that's 2 times 20 plus 1. So that's going to give us a 41. And then we're going to subtract out that first term again. Because remember, we only want it from our second term to our 20th term. So now it's arithmetic. 10 times 44 minus 3 equals 440 minus 3, which is 437. So now let's look at B. We can tell by the way the formula looks that this guy's exponential, therefore geometric. And he is already starting with 1. We want S of 5, the partial sum, first 5 terms. So let's write the formula first. A sub 1 times 1 minus r to the nth power divided by 1 minus r. So we need to first find a sub 1 in that formula would be 7 times the negative 2/3 to the 1 minus 1, which is 0. So that gives us just the 7 times 1, or 7. We know our r based on the formula, which is a negative 2/3. And we're going up to 5, so that tells us the n equals 5. So we have all the pieces in our formula. So if you're not sure where to start, if there's a formula, write the formula, look at all the variables and see if you can find the values of those variables. So we have a sub 1 is 7, 1 minus a negative 2/3 to the power of 5, because we're going all the way to 5 for our n, over 1 minus 2/3, negative 2/3. And have a little bit more room here. So that gives us a 7 times 1 minus a negative 32 over 243 over 1 plus 2/3. So notice there's a lot of fraction manipulation here. At this point, if you need to use your calculator, go for it, but we still want an exact answer. Don't leave it as just some rounded decimal. These are all fractions. You can write your answer as a fraction. So this would give us 7 times 1 plus 32 over 243 divided by, what would that be, 5/3? We added the tops and the bottoms together. That would give us 275 over 405, which would give us 385 over 81 once you reduce everything. So again, if you need to multiply top and bottom by 243, 243, distribute and reduce. That's how we get this guy here, multiply and reduce to get the results that we need. Now, problem C, notice there's no instructions there, but it does have a plus sign. So we hopefully can figure out if this is based on an arithmetic or a geometric series. So we need to see, how do we get from 13 to 21? Well, we could add, 8? And then 21 to 29, we're adding 8. So we can assume that pattern continues. And if that does, that means it's arithmetic with a common difference of a positive 8. Okay, that means we also have a first term of 13. But remember, to do the summation formula, we need to know how many terms we have, because it's the number of terms divided by 2. We have the first term and we have the last term, right? We have the 13 and the 93. We just need to know which term is 93. So even though we're being asked to do a summation, there's some math that we need to do to get from point A to point B. Again, how would you approach it? There's the formula. We're missing the n. So let's find it. We know if this was just a series with commas, that the nth term would be our first term plus the common difference times n minus 1. Well, our nth term here is 93. We know our first term is 13, and we know our common difference is 8. Now we're down to one variable, and we can solve. So this would be, if I subtract 13 from both sides, that gives me an 80 equals 8 times n minus 1. I can divide both sides by 8 or distribute n minus 1. So n is actually 11. So 93 is the 11th term. In our summation, there are 11 terms divided by 2. Don't panic because there's a fraction there. Remember, we're dividing by 2, but we're still adding two numbers together. So we've got 13 plus 93. That gives me 106. 2 goes into 106 53 times. And that gives us a summation of 583.